Hey, this is Joel Duff. Welcome back to my YouTube channel. Earlier this morning, very early this morning, I recorded a video in which I talked about my personal reaction to the revelation of the first image from the James Webb Space Telescope, revealed yesterday. Today, multiple additional images have been revealed, and at the end of that video, I suggested that I wanted to talk about how those images relate to the question of young Earth creationism. And what I was thinking was about this big problem that young Earth creationists have, which is called the distant starlight problem. Sometimes when people ask me, what's the number one reason or the number one piece of evidence that a young Earth creationist would have difficulty explaining within a young Earth, and in this case we have to really talk about a young universe model, wherein the whole entire universe is 6,000 years old. And I think one of the first things I would go to would be the distant starlight problem. How to accommodate stars that are billions of light years away. How should that be accommodated in a young Earth framework? If the universe actually isn't billions of years old, how do we explain the fact that light is visible to us from objects that are so far away? That's what's called the distant starlight problem for young Earth creationism. And so what I want to discuss here is, how do the pictures we see today not make it any easier for young Earth creationists? Because they contain billions of years of light in them. So let's explore that, because I think it's a fairly simple and easy problem to see that young Earth creationists have been stumbling around for a long time trying to come up with solutions for. So with that, let's take a look at some of the recent James Webb Space Telescope images, dive a little bit deeper into one of those images and see what it tells us about how big this problem is for young Earth creationism, or should I say young universe creationism. We've got that coming up. Yeah, so here's the image from yesterday. The very first image revealed from the James Webb Space Telescope. And it is a view very deep in the universe. We're looking through our own Milky Way, and there's a few stars in the way. Those are these very bright star-looking shaped objects here. And those are individual stars. But all the other pieces of light in this picture represent galaxies. And galaxies are made up of 100 to 400, 500 billion stars, all together in a group. And in some cases, there's groups of galaxies in this picture, and there are galaxies behind galaxies that are behind galaxies. And so this represents, although this represents only a tiny little window of our entire universe, it's still incredibly packed full of objects, right? Spread out across distances that our minds really can't fathom, although I'll make an attempt to give you some feel for these distances. But before we get into looking a little more deeply at some of these images, let's just talk about this distant starlight problem. So how bad is this problem for young Earth creationists? Well, what I've done here is I've just gone to Answers in Genesis on the left side and Institute for Creation Research on the right side. These are two of the largest creation science apologetics ministries. And I put into their search box distant starlight, and you get a long list of articles, links to videos, podcasts, and so forth that attempt to address this question of distant starlight. Right? What about distant starlight models? Does distant starlight prove the universe is old? These are all questions that they hear, right? They're being asked. Their audience recognizes that they don't have a solution for this, or a simple solution, and they're asking, how do I explain this distant starlight thing? Because it it's fairly intuitive. If the universe is massively large, right, and stars are trillions and quadrillions and quintillions of miles away, anyone's going to ask the question, well, if the entire universe is only 6,000 years old, how did the light get to us from those stars that are so far away, since it would appear that it should take some time for light to travel through space? Hence the distant starlight problem. Young Earth creationists have dreamt up a number of different hypotheses to potentially explain this. So I don't actually want to talk about the different creationist models, because I don't think any of them really make any sense. None of them are adequate. And one of the reasons I can say none of them are adequate, because young Earth creationists continue to come up with new models, right? Because they themselves recognize that the models that exist today to try to explain the distant starlight problem don't adequately explain it. And so any young Earth creationist can criticize, and I would say have very valid criticisms of any other model. And no model has sort of gained a wide acceptance among Earth creationists, even as a possible or probable explanation. So that brings us to the James Webb Space Telescope. Now, Answers in Genesis actually had an article about the James Webb Space Telescope when the telescope was launched into space back in January. And so Rob Webb, interesting name, right? It turns out Rob Webb, not related to James Webb, is actually an aerospace engineer, or at least has a master's in aerospace engineering and works for Answers in Genesis today. And what caught my eye in his particular article was, so let me read this paragraph from this article, a biblical response to the telescope. A biblical response. There's so much to be said about this particular article, but maybe I'll save some of the other things about this article for a This Week in Creationism episode. I just want to focus on this one chapter. So for this mission, the JWST will not actually be looking back in time. Rather, it will be examining distant galaxies, and here's the acknowledgement, which indeed are very far away in space, that have been in existence since the beginning of creation for thousands, not billions of years. All right, so packed away in that second sentence, he's telling us and telling his audience, okay, yes, the universe is enormous, right? It is actually very, very large. And these stars are unfathomable distance away from us. And they also have been there since the very beginning of creation, right? So all of the stars, all of the galaxies, all the objects of the universe were created at the very beginning of creation just 6,000 years ago, rather than having evolved or changed or come into being at various times. They're all created at one point in time. And when was that point in time? Just thousands of years, not billions of years ago. But you'll see that I highlighted the JWST will not actually be looking back in time. Now, I don't know how he can say that or write that sentence with any sort of straight face. When you look at the sun, right, and you see the sun, are you seeing the sun at the exact moment in time in the present? You are seeing a sun in the present, but you're not seeing the sun in the present. What I mean by that is that sunlight takes 8 minutes for it to leave the outer surface of the sun and travel through space and then into your eyes, and then you perceive, right, the visual image of the sun. And so it's like, there's the sun. I'm seeing it. Now, in real time, I'm right here, right now, seeing the sun, all right? But the sun that I'm seeing is the sun from 8 minutes ago. All right. So in that respect, I am looking back in time because I am seeing what something was in the past, not what it is in the present. And so this represents the simple problem of the distant starlight problem for creationists. Because you could say, well, you could look out toward Pluto, which is farther away from us than the sun is. And when you see Pluto, which you'd have to use a telescope to see. But when you see it, you're seeing photons, bits of light, that have been traveling for a long period of time, and longer than 8 minutes. And so you're seeing Pluto in the past, although not very far in the past, and certainly within the time scale of the known universe, or the time scale of the known universe according to young Earth creationists, within 6,000 years. The question is, what happens when you push farther away from the Earth toward objects that are so far away that it's taken more than 6,000 years for that light to reach us? What then are you actually looking at? Because you can't be looking at something that's older than 6,000 years if the universe is only 6,000 years old. And that's where one of the models for explaining distant starlight comes in, which is that those objects didn't actually emit light from what you're seeing, but the light was actually created in transit. So a 7,000-year-old looking object is not 7,000 years old. It's 6,000 years. And then light was emitted. God created light in transit for the first 1,000 years worth of light traveling through space. And then maybe the last 6,000 years it's been traveling through space since then, reaching us now. All right. And so that's a thing we call the appearance of age, where God has created things to appear as if they're very old, when in fact they haven't. He's built into the light the appearance of age. That'll become important when we start looking at some of these pictures. All right, let me read on here just a moment. These observations from JWST will not show us how or when these heavenly objects were formed, but rather what they look like by directly imaging, right? Planets, nearby stars, and so forth, by directly imaging. But he can't say directly imaging, because those direct images are actually just images of light particles, all right, photons, entering into the telescope. But those photons aren't actually they're an image, I guess you could say, of those planets and stars, but they've been in transit. All right, you're not right there at the star taking a picture. Let's just get right to pretty pictures instead of me talking over this. All right, so we're back to our first image. And so what I want to emphasize here is we just want to talk for a minute about just how big, what the scale is here. This is a star. This is a star. This is an individual star. Individual stars, okay? And there's some small ones here too, all right? So let's take a look at those. Here's another one here. So now what are you looking at when you look at these stars? What you're looking at with those stars is these are stars that are in our Milky Way, right? We're the Earth going around the sun. Our sun is one sun among 100 to 400 billion other suns that make up our Milky Way galaxy. And so we're in a galaxy. And in order to see outside our galaxy, right, we have to look through our galaxy into the space between galaxies and then across that space to other galaxies. And to do so, we look through our galaxy, but it's hard to find a space to look through it where you're not going to actually bump into a star. And so that's what we're seeing here, right? We're looking at a tiny, tiny, tiny little window. You can think of it as just like taking a laser pointer and pointing it out through our galaxy, because that's about the width of the, of the distant, the area we're looking at up close. And we go out and we are going to see some stars. The bigger stars are ones that are closer. The smaller ones generally, I mean, there could be differences in sizes of the stars, but we're going to say they're, considering them be within some order of magnitude, generally the tiny ones are ones that are much farther away, and the larger ones are a whole lot closer to you, which is why they appear larger and they're brighter. Now, what are all the other objects we see here? All the other objects you're seeing here are all galaxies. Right, and each galaxy. So here's let's get a good galaxy here. I like this galaxy right here, right? Because you can see a nice spiral galaxy right there. That galaxy right there is probably very similar to our Milky Way. So let's say 100 to 400 billion stars, And yet 400 billion stars isn't as bright as this star here. So it doesn't take any, you don't have to be a brain surgeon to understand that 400 billion stars being less bright than one star means that those 400 billion stars are a long, 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 long way away. All right, they're way farther away than this other star. And let's zoom in a little more. All right, if we zoom in, whoops, yeah, I meant to zoom in a little bit before. So if we zoom a lot more into this image, what we'll see is that here's our what were very tiny stars in our Milky Way. As we're looking way across the Milky Way, 50,000 light years away, and we're seeing a star there. And then here are these galaxies. All right, so here's an entire galaxy behind this star. So billions of stars right here in this bunch. Another couple billion stars over here. All right, some billions of stars here, but closer, all right, than these other ones. And then you see what they circled in blue here are these tiny little dots. But they're not actually dots. If we zoomed in even more, they're actually small galaxies. So this galaxy is 1/10 or 100th of the brightness of these other galaxies here. And so they're another multiple times away. All right. So if this star is 25,000 light years, say, away, all right, and this galaxy is 100 million light years away, right, or maybe even 1 billion light years away, then this is going to be a couple billion light years away. And as you look across here, you'll see there's lots of little dots all over the place. All these dots are galaxies that are way, way farther behind these other galaxies. And then you have interesting phenomena like this galaxy right here, which is quite warped. And if I go back, you'll see that I love this one right here. This galaxy right here looks like it's stretched out. And here's another one that's stretched out and another one over here. But there are other things in front of it that aren't stretched out, right? These are galaxies that are way far away, but they're also had their light bent as it's coming to us. So as space is warped by different amounts of matter in space, especially things like supermassive black holes, the light from those galaxies, because this galaxy very well, let's go here. This galaxy right here, they may very well be behind something that we can't really see very well. And its light is then bending around it. And so we see it as this warped image when it gets to us. All right. Now, if you just think about that from the perspective of young Earth creationists and the first model I gave you for how they might explain like where distant starlight comes from, if this is said to be, let's make up a number, we'll say 4 billion light years away. Well, it can't be 4 billion light years since the universe is only 6,000 years old. And so how might we be seeing that? Well, maybe it really is 4 billion light years in terms of the distance away, but maybe God created all the light in transit. So not only did he create this galaxy, but he also created all the light emitting from the galaxy and then created these long strings of light that go all the way 4 billion light years worth of distance across the universe to the telescope. And all of that was created at the moment of creation. But you understand when you look at something like this warped light, you understand that this also so God also had to then have created the warpage in the signal from the light coming from those. Right? Couldn't have just created in a straight line. He had to actually acknowledge that this light would have bent around this other place, even though it never actually traveled around that. I mean, he just created it already bent around something. It's these kind of features in the light that we're seeing from different, cosmic entities, all right, that really has made a lot of young Earth creationists has really made them dismiss the whole apparent age thing, because it just looks like God's fooling us, right? He's just creating a false image of the history of things, because those aren't really real, all right? It's like the light that we're receiving didn't actually come from an object. It was just photons flying through space that were created to look like they had traveled past something and bent, except they never did travel by something and bend because of the gravity. Here is our solar system. And Voyager, the Voyager spacecraft, which were sent off into space in the late 1970s, have been traveling through space. And in fact, they've actually exited what we consider the solar system proper. All right. They're out into outer space outside of the solar system envelope. And that's taken, a solid 30 years to do, flying through space. I looked it up today, and Voyager 1 is 14,587,267,055 miles away, although a lot more miles away after a few hours now. But what I'm most interested in is how long does it take to get a signal from Voyager 1 to us? All right, if you wanted to send a message to Voyager 1 and tell it to do something like a course correction, you would send that signal from here, and it would take 21 hours and 38 minutes. And that's how long it would take. And we can measure the time that it takes to get there and the signal to come back. And it would be double that, right? It takes that much time to get there and not much time for it to send a signal back saying, I got the message and here's what I've done. So that's only 21 light, right? That's 21 light hours and 38 minutes. All right. So that's light distance that they're traveling. Now, if you look at the closest star to Earth, it's 4.246 light years. So the other one was just light hours to get to the edge of the solar system. But in order to get to the closest star, so you leave the solar system and you'd have to travel through space where we've not identified anything between us and this next star, anything of significance. And we get to Proxima Centauri, which is 4.246 light years. So it's going to take that long just for light to travel there. So when you look at those two closest stars to us, it's just like looking at the sun, but you see the sun just 8 minutes later. So it's very likely the sun looks very similar. If you were right at the sun right now, it would look very similar to what you're seeing 8 minutes later. For Alpha Centauri, you're seeing something 4 years later. It's not even in the same position, right, in the universe at that time, because it's traveling very fast with respect to our solar system. And so 4.246 later, we see it as like, here's that point in the sky, here's where it is, but it's not actually there, right? You're not actually seeing reality at that moment. You're seeing reality from 4 years ago. And a young Earth creationist really doesn't have a problem with this, because they'd say, well, that's like it's 4 years. So God created Alpha Centauri, and light has been emitting from that star, and it's traveling to us. And 4 years later, we see it. And that's what's been happening for 6,000 years. But you know what's going to happen? We already know what the problem is, because I've already said it. But let's just keep following this path. Our galaxy is approximately 105,000 light years across. That's considerably more than 6,000 light years across, right? It's a big galaxy. We're 28,000 light years from the center of our galaxy. And so it takes a long time for light to travel. If you were at the edge of the galaxy and you're emitting light at light speed, it's going to take tens of thousands of years, not 100,000 years, for that light to go all the way across the galaxy and for a person on the other side of the galaxy to see it. Right? That very clearly shows you what the distant light problem is. Right? If all objects were created 6,000 years ago, so boom, there they are, and they start emitting light, we would have to wait around for another 95,000 years. Actually, for us to see the rest of the solar system, we'd start to see more and more and more of it all the time. We'd see stars popping into existence every single day, right? Because the ones that are more than 6,000, the ones that are 6,000 light years away, we would see everything from 6,000 years and closer to us. But anything that's 7,000 light years away, we couldn't see at all, because the light wouldn't have gotten to us yet. But in another 1,000 years, all of a sudden we would see it. So what would the universe look like to us as we look up at the universe? It would look like stars popping into existence. Every day there'd be new stars. In fact, and then eventually, a long time from now, we'd start seeing galaxies starting to appear. But is that what we see? No, we use telescopes. We look out and we see galaxies we see stars. We see galaxies behind those. We see galaxies behind those galaxies. And we see galaxies even farther behind those galaxies. Hence the reason to either say that all the light already existed from, God created this star and he created the beam of light going all the way to the other edge of the solar system, such that when he created somebody here, all right, or let's say, the Earth was over here, we would immediately see or think that we see this star over here. Now, in fact, in an old age model, this star might not exist, right? Because 100,000 years later, it might not exist. It certainly doesn't exist in that location. And maybe it blew up as a supernova, 1,000 years ago, but we won't know that, for another 99,000 years. All right, so the distant starlight problem is a pernicious problem for young Earth creationists because it is one of the simplest things you can look at and say, the universe is huge, there's vast distances, and the simplest explanation is that it takes a long time for light to get from one place to another. And the very fact that we can see light from 1 billion light years away suggests that the universe is 1 billion years old. It is just the simplest explanation for the data. The only reason a young Earth creationist would attempt to even come up with another explanation for why the universe looks like it does is because they're committed, right, to an interpretation of scriptures that says that the universe is only 6,000 years old, and every single one of those stars can only be 6,000 years old. If you're committed to that, then you can't look at the data and say the simplest explanation is X. No, the simplest explanation is that the world looks like it's 1 billion years old. All right, that the universe looks billions of years old. And you have to say, well, the simplest explanation must be wrong. All right, the obvious intuitive answer must be wrong because I have this other truth that says you're wrong. It's actually only 6,000 years old. So far, they haven't come up with anything that's at all compelling in terms of like an alternative explanation. All right, let's go back to a couple things because I wanted to say also that you can see this everywhere you look in the universe because the light has to travel from one end to another and to us. All these objects are moving in time, and as we look at them through the years and through the decades, we see their motion. So that's an added complication to any model that suggests that, well, maybe the starlight traveled to us much, much faster in the past than it is in the present. It would also have to carry that information about motions, which makes sense to us in our present day calculations of modeling how these star fields would move around and how stars interact and how black holes work and so forth. All right. Our physics does amazing work explaining some of the things that we see in these images that in most young Earth creationist models would have to alter even our basic understanding of physics in order to accommodate this data. I did want to show this image because it represents the difference between our view of the universe in the past versus the now present, which is as of today, all right, this afternoon. This is a clip right from It's a Wonderful Life, the movie from 1946, which used an image from a telescope taking a picture of Stephan's quintet, and in which these galaxies are talking to each other, if you know the opening of A Wonderful Life. It's a Wonderful Life. All right. And at the time, this is what we saw, and we were amazed. Like, there's galaxies out there with thousands of stars in them. And the Hubble telescope took a much better picture of this, but then JWST comes out yesterday and shows us this amazing image of multiple galaxies in fairly close proximity with actually two galaxies that are running into each other. and mixing with each other. And although that sounds like a cataclysmic event, which in a way it is an enormous cataclysmic event, but you have to remember stars are light years away from each other. So two galaxies can actually slide right together, and some of the stars will interact with each other in a violent way in terms of actually running into each other. But most stars will glide past each other, and then the gravitational fields will eventually cause another, combined, it will create a combined galaxy from that. And so what we see when we look out in outer space is we see all these dynamic elements of universes that are changing shapes, right? We see places like the Carina Nebula in our own Milky Way, which is huge gaseous fields where gravity is actually helping to form new stars. And so we see the development of galaxies, the death of galaxies, black holes eating up stuff, and the origin of stars themselves. And what JWST is I'm pretty sure going to show us is much, much better data, all right, better pictures, but more importantly, the actual data from spectra that will tell us more about the planets that are surrounding these stars, because most stars now, it appears, have planets, and we'll see those planets being formed. And so going back to Webb, the author Webb from Answers in Creation, where he says that, all the stars were formed 6,000 years ago. But another thing we see as we look at these pictures, I should be showing you this one from the Webb telescope, because this is the same thing, all right? That compared to that, that's how much crisper the image is. And so again, these are close-up stars from our own galaxy. And this gas field is actually in our galaxy, and then everything in the background is way past our galaxy, and those are other galaxies there. There's probably 100,000 galaxies in this picture. And what was I saying? So Webb, he's talking about how all the stars, were there 6,000 years ago, or everything was formed, the universe 6,000 years ago. But when we look at the universe, we see a dynamic place where we see the origin and death, all right, of objects in the universe as it is a chaotic, constantly changing place. That's contained in the starlight that's coming to us. And so that has big implications, because it suggests that if God actually created all the light in transit, he created a portrait of a universe that is dynamic and evolving and self-creating, all right, new components for itself. And after some of the components are actually being absorbed by black holes and so forth. And that would be in the original creation, right? Before Adam's sin, before Adam corrupted not just the world, but for young earth creationists, he corrupted the entire universe. And so the distant starlight problem is a question that goes beyond just how do you explain how light got across billions of quintillions of miles of space? Like, how did it travel across there? It's about the actual information that is contained in that starlight and the story that information is telling us, and how we're, the things that it leads us to see about this universe. So Webb is wrong. We're not just looking at the images of those objects today, right? We are looking into the past. You have to be looking in the past. Like I said before, you're looking into the past if you see the sun, and if you see Pluto, and if you see the closest star, you're looking at the star from thousands of years ago. It only makes sense that if you look to the other side of the Milky Way, you're looking hundreds of thousands of years in the past. And as soon as you go beyond 6,000 years, you have to ask yourself, how can I do that? How is it possible that I'm able to do this, that I'm able to see that far? And then you ask yourself, how is it possible that I can see the warping of space, right? On this massive level where the matter, dense fields of matter in different parts of the universe, light is having to bend around that, right? Or more properly, I should say, the matter itself is bending space-time. And so as it bends space, all right, Light moves along that bent space and warps the image of what's behind it for us. And so, how is all that done in a young universe? If the young original universe is perfect, and there is no origins of stars or deaths of stars, why do we see contained in the information coming to us massive deaths, of billions of stars in a universe that has septillions by septillions of stars, including septillions of planets? Yes, the universe is just too big for a young Earth. It's just too big. These images across, that's 100,000 light years just for the light to travel across here. So that's 100,000 and another 100,000, another 100,000, another 100,000, 100,000 here, 100,000 here, 100,000 here, 100,000 here. You are looking at 1 billion years or more for light to transit just this little tiny millionth portion of the galaxy. All right, sorry, the galaxy, of the universe itself. 1 billion years, all right, of light to transit across that. And yet we're able to sit back and actually observe, right, the light from billions of years, billions upon billions of years. And JWST is allowing us to look farther back in time. I mean, that's what they say. It's like the original telescopes, they couldn't see 3/4 of what you're seeing here. All right. And what they did see was very blurry. All right. And then we start to see more clearly some of these galaxies. We understand, there's galaxies, right? That was a revelation at one time. And now there's galaxies behind those galaxies. And there's galaxies behind those galaxies. And in these new images, we're seeing thousands, if not tens of thousands of new galaxies just in one image that we've never seen before. And then there's little tiny pinpricks behind that suggests that if we built a bigger telescope, we'd see even more galaxies, right, behind those galaxies. It's amazing, absolutely incredible, impossible to wrap your mind around how far away this is, how much light we're talking about, and the total amount of matter, right, in the universe. So the distant starlight problem is not going to go away for young Earth creationists. Well, unless they come up with a plausible answer to it, but they've been working on it for many, many years. I think it is one of the toughest challenges for any young Earth creationist. And I think it's a completely valid question to ask anyone who believes in a young Earth, how they explain the distant light problem, because it best represents and it causes them to confront this question of what is the universe? How old is the universe? Why does it look the way it does? All right? Acknowledging that God is the author of the universe. Why did God make it look this way? Right? And how did he make it look this way? It's a great place to start a conversation, to get one thinking about the importance of those questions and the possible answers to those. All right. Thanks for listening. I'm sure there's going to be incredible images from the James Webb Space Telescope in the coming years. And we're going to learn a lot more about this dynamic universe that we live in as we go along. Thanks for listening. We'll talk to you later. Bye-bye.